Welcome to the ProtaSteel presentation for today. Let me give you a few things about myself. I'm a structural engineer by profession, and I've been in this business for the last 30 years, the business of analysis and design and modeling and detailing, and today I'll be taking you through this ProtaSteel presentation. Different companies have developed different softwares for all these stages. So if you were to look around, you would see that there's a modeling and analysis. They're softwares which are dedicated to doing just modeling and analysis. So you must have heard of lots of these names like STAAD and SAP and Midas and S-Frame and Robot and ETABS, and there's so many others. Maybe hundreds of other softwares which are available, some more popular than the others. But what I want to emphasize right now, this is one step. This is not the entire process which we as structural engineers and designers have to go through every day. This is just one step of the process, the modeling and analysis part. And then, of course, we have to do the design. And sometimes some of these softwares which I mentioned above, they do take up some of the design steps, but usually it's kind of related to the element design, like the frame element design. Usually doesn't really go beyond that. But then that's not all we do. We do component design as well, don't we? We do, by components, you can think of any specialized part of the structure which needs to be designed and analyzed as a separate entity. So one example would be your steel connections, for example. And now here again, we see a host of different software which have entered the market, like Procon and Limcon, and all these are for connection design and other components of your structure as well. So once again, we are faced with a host of new software which we have to pay for because the modeling and analysis is done by different softwares. The design is done by different softwares sometimes. The component design is once again done by other softwares. And it doesn't end there, does it? It continues with the detailing and drafting, and here we are faced with other choices. So we are bombarded with all these hundreds of thousands of different softwares you have to choose from and pay for, obviously. So in the detailing world, we have to produce drawings. So we have AutoCAD, we have BricsCAD, we have so many others. There's no need to mention. But the point being that at every step of the process, our job is not finished. Our building is still unconstructed. Our structure is still in our minds. It's not being finalized. It's not being constructed yet. But we are continuously changing softwares. We continuously going to these different software providers and producing model after model after model to get to where we want to get to. And then it's not the end yet as well. There's fabrication. There's fabrication literally means you're down to the millimeter now. And here we're talking about very advanced, very expensive software suites like Tekla Structures, Advanced Steel, BoCAD, and this is what we have to go through, unfortunately, every day in our lives. And then there is structural BIM. We have to coordinate with other companies. We have to coordinate with other suppliers. We have to coordinate with other subcontractors. So we use Revit, we use Tekla Structures again. There are other options as well. But what I wanted to emphasize with this slide is that we go through several steps as structural engineers. And there's the modeling, the design, the component design, the detailing, the fabrication, the structural BIM. And for each of these steps, we have to get a software, because obviously we're not living in a world where we do these things by hand. So for the modeling, we have a software. For the design, we have a software. For the detailing, we have a software. For the fabrication, we have a software. And these softwares are usually not compatible with each other, let me emphasize. There are many cases in which a lot of the work has to be redone because although the world is trying to get to a common standard by which these programs can communicate, but that common standard by definition is not proprietary. And if it's not proprietary, what that also implies is that there will be loss of information. So these programs, although they do occasionally speak to each other, but there is loss of information. So there's a lot of work which needs to be redone. And we eventually end up spending many, many more hours than we could have. So this is what we're faced with. Now, modeling and analysis, a software. Design, a software. detailing another software, fabrication another software. Now what's happening over here on your right? I'm trying to paint a picture of what ProtaStructure suite is all about. If you see on the right, I'm going to go through this again, from modeling to design to detailing to fabrication to structural BIM. What if we had all this in one packet? What if all this was done by a single software which took you from greenfield to the finished building, from modeling to analysis to design to detailing to drafting to fabrication to communication of the results with everybody else? That would save us time. That would save us money. And that is what ProtaStructure is all about. Now, let me just summarize all that I've said. ProtaStructure, there's a bidirectional links to everything. There's BIM links, there's automated interactive detailed drawings, there's CNC data, there's shop drawing, all that we talked about a while ago. This is general purpose analysis and detailing and design. There's design reports, there's images, there's documentation, everything in one packet called ProtaStructure. Imagine what that can save you. Now, obviously, today we will not be talking about all these different parts of ProtaStructure. There are different webinars, there are different training programs which we do for that. Today, we'll be focusing on ProtaSteel only. And ProtaSteel, what is ProtaSteel? ProtaSteel is the steel structure part of this whole suite, which we will be discussing, and I'll give you a lot more information on that. And we can, from this point onwards, talk more about that. So today's webinar, which is about ProtaSteel 2021, I'll give you a few hints about what we'll be going through. So we talked about connection design and steelwork detailing. What we mean is integrated, intelligent connection design using a very comprehensive range of flexible connection macros. And these are driven directly from the analysis results from ProtaStructure. So don't forget, we're not talking about different programs here. We're talking about modules of the same program, which are tightly integrated. So once you're done with your ProtaStructure analysis, the whole model which you have created painstakingly is transferred to ProtaSteel. And you don't have to remake your steel model once you're in ProtaSteel. It's already there. All you now have to do is detail the steel work. So once the model is inside with all the forces from ProtaStructure, you can go on to automated steel connection design using our revolutionary Intelliconnect. I'm going to be talking about that in a while. And we create constructible arrangements with a lot of ease. There's full connection design reporting with step-by-step calculation documentation. There's a creation of complete steel detail drawings. Obviously, that's where you spend most of your man hours. And that's the next thing is the shop drawings, the shop drawing production, the assembly details, and even the full cutting lists. So all this we'll be going through today, hopefully, in the next hour or so. And I'll be trying to show you what we can do with ProtaSteel. So let's see it in action. So here we see ProtaSteel. Now, what is ProtaSteel? Let me start by repeating what I just said a while ago. ProtaSteel is a steel modeling and detailing software. By modeling, I mean you can actually sit down and model your entire steel structure right down to the nuts and bolts. So as you can see on the screen, you do see nuts and bolts on the screen. You see welds on the screen. You see cuts on the screen. You see the steel beams and everything being modeled right down to the final detail. So this is the kind of environment which ProtaSteel provides you. And obviously the purpose is not just to create a 3D model, but to produce shop drawings from it, to produce connection drawings from it, to produce other fabrication drawings from it. And this is what we will be talking about. So the basic philosophy over here is once you're done with your model in ProtaStructure, you do not have to recreate that model. You just transfer that model into ProtaSteel, which is just a click, and your model is all your beams, all your columns, all your braces, all the structural elements are there. If some of the elements are missing, if some of the non-structural or secondary elements have not been modeled, you can add them over here, and you can finish off your your basic structure. So now let me start by the actual presentation. So here is the model I want to use to take you through today's presentation. Now, it's a very simple model, so don't think that this is all we can do. Towards the end, I'll show you a few other things just to give you an idea of what kind of things we can go through. Now, like I said, the first step is to transfer this model, and this model has been transferred. So we see that the steel work is here. What you immediately notice is that the connections are not here. Nothing is connected. But then that's what ProtaSteel does. We have the purlins, we have the trusses, we have the columns, we have the beams, but there's no base plate, there's no beam floor connections, there's no splices, there's no truss connections, nothing. It's not connected. But it doesn't mean that only the steel is there. What it also means is that all the loads on the structure, which have also been transferred from ProtaStructure. So now that we're going to make some connections over here, we shouldn't forget that it already knows all the connections. So the first thing I want to talk about is the suite of connections which we have. Now, on the top of your screen, you will see some icons over there, and these icons cover a huge range. It's a bit misleading if you see that you might be used to some other software which have maybe seemingly more connections, but in ProtaSteel each connection represents multiple cases. So it's actually a very complete list of connections which we have, and the idea is that normally, let me just open one of these connections for you to let you know what I'm talking about. So this is a stiffen end plate connection, and if you see there are so many things which the user would eventually have to enter if he needs to make a proper connection. These are geometric dimensions, the information about the thicknesses of the plates, there's information about the bolts, the bolt assemblies, the bolt diameters, the tolerances, different types of holes, the washers and everything. There's a lot of information which will need to go into the welds. Now, if you just ask yourself, how much time will it take you to enter all this information? And even for advanced users who are in the business and who immediately recognize the connection because they've done it thousands of times, even for them it'll take them several minutes. But if you're talking about a newcomer into the business, it can take a lot more. So what is the fundamental idea in ProtaSteel? The idea is that if we can design a system in which the user doesn't have to enter any of this information, these informations, none of it, or as little as possible, then how can that be? So the way in which we achieve this is by importing all the loads from ProtaStructure, so that all the thicknesses of the plates, the number of bolts, the sizes of the welds are all calculated and designed by ProtaSteel according to the various standards which it supports. So and also the information which is not directly related to analysis, things like distances between bolts, the exact axis on which the bolts will be placed, etc., are all taken from company standards. So we've brought it to a point where all you need to do, for example, let me just take you through some of these connections so that you see you can see what I'm talking about. So for example, I'm going to make a stiffen end plate connection, which is a beam to beam connection. All I need to do is just pick a beam, the main beam, and a secondary beam, and that's it. And what I'm assured of at this point, as it has taken the loads from ProtaStructure, it has designed the plate thickness, it has designed the number of bolts, it has designed the weld size which is required, it has done all the other minor detailing requirements, and it has created a connection. So although I can now go into this connection and make changes if I wanted to, I could go and actually write a few different things over here, change the thicknesses, change the bolts. I could do anything manually, but the thing is I don't have to, and that's what's primarily of importance over here. So what you save is a lot of time. If you think about it, you will be going through hours and hours and days of actually just entering this kind of information. And this is what ProtaSteel saves you from. It will not ask you to enter the loads. It will not ask you to enter the thicknesses, the weld sizes. It will be doing all that in the background. You will be just clicking away, basically. So if you were to make, for example, a beam-to-beam connection, so let's say this is the main beam, and we have this beam and that beam framing in on both sides. So it's just made that connection, as you can see, extremely quickly. It's made the notch. It's made the connection from both sides. There's a common bolt going through both of them. So these are the things which you need to think about. This is the time it's going to save you, because otherwise you will not be sure of what you've done over here. So what kind of connections do we have? Let's quickly go over those. So we have the stiffen end plate connection, which we just showed you. There's the beam to beam end plate connection. There's the fin plate connection, and mind you, all these work with columns as well. So there are angle cleat connections. There are splice beam to beam splice connections. There's the stiffen end plate with the columns. There's the beam to column end plate connections. Now we have the moment connections, which are like the Haunch connection, for example, the directly welded connections, the flange plate moment connections, the extended end plate. These are all your beam to column moment connections. And then we have your bracing connections. So we have bolted gusset, we have corner gusset, we have welded gusset, which is for trusses, we have corner welded gusset, we have your purlin and gird connections, we have your splices, and we're going to be going through little connections as we go through the webinar. So without wasting too much time, let me just show you how quickly these things can be done. So let me just pick up this Purlin connection and show you how quickly I just made a Purlin connection over there. Now, like as I said in the beginning, these connections represent a multitude of cases. So you can see that this single connection over here, actually you can do 5 different types over here. So let me convert it into the folded plate type connection. So with one single click, one single change, that single connection turns into an entirely new different type of connection. We'll be talking about this as well. Let me talk about splices, for example. So we've got several points in our model. So mind you, this model is now the final model. So the splices need to be in there. And just by clicking the 2 columns, we are being able to create the splices on the go. Nothing is required. We're just pointing and clicking. I'm not entering the plate thicknesses. I'm not entering the bolt number of bolts. Everything is being taken by my company standards, by some design algorithms, by the loads which I already have. So let's do a few more. Let's do some beam to column connections over here. So let's come over here and let's do some beam to column. So I'm going to use the same stiffen end plate, and I'm going to let's see how I can connect this beam to column over here, and immediately this stiffen end plate connection is created. Let's do another one. Let's do this is angle cleat. This is this, this is the end plate connection for the column. So let's do this column and this beam, right click, and we have an end plate connection. Let's do the same end plate for this incoming beam as well, and we have another end plate connection. So it's extremely simple. It's just a matter of knowing which connection you want to use and just pointing and clicking, and then not worrying about the actual design of the connection, because that's going to be done for you. So let me show you a few more examples, a little more complicated one over here, which is interesting. So let me go over here, and we have a column over here and a beam, and the beam is connected. It's a fixed connection. So I want to make a haunch. So let me go to my haunch connection. Where is it? It's over here. And let me just select the column and the beam, and immediately I get my haunch connection. Now, from the other side, let me flip it over. From the other side, I have another beam coming in, as you can see on the screen. But now these stiffeners are kind of getting in the way, because this is a simple connection from the other side, and I want to connect that. So what I want to do is I want to use the stiffen end plate connection once again, and I'm going to say this column with this beam, but I want to say that please use these existing stiffeners. And the program automatically recognizes that I can use these existing stiffeners, and it's made a connection over there. So with this very simple technique, it's being able to connect the other side as well. Now, let me give you another example of something similar. So over here, for example, I can come and there's a beam framing into another beam. So let's use a fin plate connection, for example, over here. Let's use fin plate. This is the main beam. This is the secondary beam, and I use a fin plate connection. And once the fin plate connection is done, I want to connect this bracing, this horizontal bracing in there as well. So I go to my corner bolted gusset, and I say connect this beam with this horizontal bracing, but I have a limiting barrier over here, which is this plate, existing plate. And immediately it makes that connection. And all I need to do now is just go inside and change this dimension to something which is suitable. And immediately I have a non-clashing connection over there. This is one very good example the way the macros can be used together with each other. Let's make a few more connections for bolted gussets, for example. So here is a beam. It's got two incoming braces. So I'm going to go to my bolted gusset connection. As simple as that. Just select the main beam, select the secondary members, right click, and your connection is ready. Obviously, there are a host of options inside the connection. I'm not going to go into those. But once you're inside the connection, you can make all these changes and modify it according to your liking. But like I said, you won't need to do that for most of the time. So bracing connections I showed you. Let me do a few sag rods, for example. So we have some sag rods over here. Let's try to make a sag rod connection over here. So yeah, so let's do this and right click. So immediately we have the sag rod connection. Let's go again. Let's make this, and that's it. It's put the hole around it. So these are very easily made connections. Now let me show you a base plate, for example. So another thing I want to mention is that while it's doing these connections, it's also using your company standards. So for example, this column over here has a fixed connection to the base. As you can see, all the constraints are fixed, whereas this particular one is hinged. The rotations are allowed. So when I use the same connection on it, so this is the base plate connection, for example, one of the base plate options we have. When I use this on this column, it creates a hinged connection. But when I use the same connection on this one, it creates a fixed connection because it knows from the end conditions that this is a connection which is fixed, and I need to model according to that. And like I said, once again, you can go in and modify the connections as and when needed. Now, you can obviously put in anchor bolts over here. It asks for a point. I don't want to enter a point. I just want to show the base plate. And the moment I show the base plate, it recognizes the holes in the base plate and immediately puts the anchor bolts. I noticed that they're both pointing in the same direction. So I just go in there and give it a different rotation. I can give it any rotation I want to make it point in the other direction. And my anchor bolts are ready as well. Now, okay, let's do a few more just to give you an idea. For example, I can go over here. Now this is something new which we didn't have in the previous version. So now we can use ProtaSteel to create holes inside beams. So for example, a lot of times for architectural requirements and sometimes for structural requirements as well, you need to have holes inside your beams. Sometimes things are passing through them. Sometimes you have a castellated beam. So you can do that all manually. ProtaSteel is not a software which is only limited to macros. Let me just say that. So if you, at any point you realize that the macro or the connection is not available for what you want to do, you can use ProtaSteel in exactly the same way like you use your very advanced softwares like ProtaStructure, in which you can model just about everything you want manually. It is the same exactly over here, but obviously we want to have as much ready-made connections as possible as well. So let me just make holes in this beam over here. I'm just going to make some holes in there. So just select the beam, and there I go. Now, obviously there are different options over here. I just go and select the macro which made those holes, and what I can do is, for example, I can go and say I don't want the stiffeners. I don't want the stiffeners around them, and I say okay, and the stiffeners are gone. I can go back inside. I can say I want hexagonal holes rather than square round ones. I can make them rectangular, I can make them hexagonal. I can go and say I don't want spacing, I want to give it by count, so let me say give it a number of 9, and there I go, I've got a castellated beam now. So depending on my architectural requirements or my structural requirements, I can do all these things extremely quickly and then copy them around and move them around in the model, and it'll intelligently realize what you're trying to do. Now, let me give you a few more, something new we added to the stud macro. The stud macro is the same as it was before, but we've added a few things, and that is that previously we did not have this option of equal distance and a start and end offset. So previously we had this distance option only. So in the distance option, you could enter distances, but then you would have to enter different distances for each different beam, because all beams would be of different lengths. So for each different length of beam, you would have to have a different input. So this is a different kind of input in which we have a start and end offset. It's the 350 millimeters from the start and the end, and then a guideline distance of less than 750, so maximum of 750 millimeters or less. So when I apply that, what I see is that if I click on the macro, I can select this beam, and I've got these studs on it now. But when I select a smaller one, it automatically uses the same input to reduce the number. Otherwise, it previously would have overshot the beams. So now we have, we can just point and shoot, and for each beam, it will use those standard guidelines to produce the studs which I want for the shear connection, for the shear connections. We can put in handrails. So let me just put in a few handrails. You can just show it a beam and right click again, and your handrail will be created. Let's put another one for this beam. And the other one is created as well. So now we see that these two are not connected to each other. So what we can do is there's a handrail connecting macro, and all you need to show is one element from the first handrail and another from the second handrail, and it will just connect them seamlessly. And it's not just the top plate, but the knee plate and the toe plate have also been connected. So with a few clicks, you can see that you're able to create all this in ProtaSteel. For example, what else can I show you? I can go through the flow modeler, for example. So if you have checkered plates, if you have grating in your structure, what you can do is all you need to do is show it the 4 beams which are form the perimeter of your floor, and that's it. And immediately the floor will be created. Let me do another one over here. This one, and then this one. Yeah, right click, and there you go. So let's look at it from the bottom. It's called the stiffeners in there as well. So with a few clicks, you can see I can produce the flooring as well. People are usually very scared of 3D modeling, especially the consulting companies, because they feel that it's a very different area of expertise, which they would then need to learn, and it'll take them years and years, because obviously other people have spent their entire lives doing steel detailing. But what I wanted to show you was that this is not that difficult. It's very, very easy, in fact. So let me just go through one little example over here. Let me do a connection over here. Let me do your stiffen end plate again over here, and show these stiffeners, right? So and let me do a corner bolted connection over here for the top as well. So I want this column and this brace are connected to this top plate as well, and immediately we have the connection. And once we're done with this, I can immediately select this column and say right click and say highlight the assembly. Now this is the assembly is what is going to go to the shop floor, and I can say show only, and immediately I have my column assembly. I can swing it around, flip it around. I can see whether I'm satisfied with the connection or not. So in with a few clicks, I can immediately see that if the modeling I've done is okay or not. I can go back, I can say show all, and my structure is back in action. Now, so the summary of this part is that it's while it may seem to be daunting to many, as I just shown you, it's just clicking. There's no more to it. All you need to know is know your connections, and which you obviously do as consulting companies. All you need to do is know what you want to do, and you just click away, and the program is going to do the rest for you. Now, let me just start this again before I go into the next section, because I want to talk now about your connection reports. Now, once you're satisfied with the connections, obviously you want construction as your connection reports, connection design reports. And here we are talking about a huge market. If you remember in the beginning, we talked about all these different kinds of software which are used for the modeling stage, for the analysis stage, for the component design phase, and for the detailing and all that. So for the steel connections, there's a whole market of different software. But with ProtaSteel, you get them all included, all bundled together into one software with the ProtaStructure suite. So while I had claimed that these connections, as you're modeling them, they're also being designed and checked. So this is what I'm going to be talking about right now. So the first thing I want to show you is a color coding scheme, which is over here. When you turn it on, the whole structure turns into white. And then you can start, you don't have to do this. I'm just saying that if you want to make use of this color coding, it will be helpful. And all you need to do is now continue as you did before. Let's say if I'm going to make a Haunch connection over here, and I've purposely made some of them to fail and then make them pass again to show you how things work. So I'm going to make this Haunch connection over here. I'm going to select this column, select this beam, and immediately we see a Haunch connection. Now what I want you to notice is that the Haunch connection is red. Now what that means is that when the program did the design checks, it found out that some of the plates or some of the bolts or some of the welds, there was something which was not according to the code requirements. That's when you see the whole connection as red. Otherwise, you're going to see the connection as green. So two primary colors. It's going to be either red or it's going to be green. Now, if it's green, then it's fine. If it's red, then it means there's a problem. And to see the problem, what you need to do is you need to create the report. So let me just go ahead and create the report for you. And there we go. So as you see, as I scroll down, you see all these checks have been done, and we see the green passes means that nothing is wrong. I keep going down, and there's a fail over there, and it's related to the column intermediate stiffener. The thickness seems to be, although it's very close, but it seems to be not enough. So I see why it's failing. So now I come back to my model over there. I go into the connection, and I go to my stiffener plates, and I make them slightly thicker than what they are. And I pull it to the side, and I say okay, and there you go. The connection is now turned to green. And if you go back into the report, you will see that that has also changed, and you can now get the final report. Let me do another one over here, make it fail and then make it pass as well. So let me go to this flange plate moment connection over here, right click, and it's red. There's a problem with it. I can go inside the report. I can go inside the macro. I can go inside. When I right click, there's a place where I can make the report. There you go. So here we see there are some failures relating to the top flange plate checks. The top flange is failing. There's some failures related to some other plate failures. There's a bottom flange failure as well. And there's a group bolt shear resistance failure. Several failures over there, which I first purposely put in there. So I come back and I modify the connection. I load in my preset, put it to the side, and there you go. Now it's green. Green means that everything is clear. So it's as simple as that. You just go through your connections one by one. They'll turn green. If there's a problem, they'll show up as red, and you can make the necessary modifications accordingly. Now, and then you can get your reports from that point onwards. Now, what I want to say is that this feature in itself is a reason for you, should be a reason for you to own the ProtaStructure suite, because only for this you will be paying a lot of money to our competitors. And once again, not only will you be paying a lot of money, but the information once again will need to be transferred from your whatever finite element software you're using into that software, and that will create problems because the loads might not be transferred properly. There'll be hundreds of load combinations which might not be transferred correctly. There could be human errors, but over here it's all integrated and it's all one little piece. I've deliberately increased the load in this beam ridiculously high, and I'm going to use a connection which is extremely inappropriate for such cases. I'm going to use the fin plate connection, so it's going to make a horrible connection, and then I'm going to connect it for you. So let me go to the fin plate and try to make a fin plate connection over here. So as you can see, it's made up. It's a 30-40 millimeter plate is put in there. But now I'm going to just go inside. Sorry, go into the beam and reduce my load level, and immediately I can see that my connection has changed, and when I update it, it's turned into green. So these features are extremely easy to use. The color coding is extremely, if something is not being designed, let me just add that because I forgot to say that, it's either green or red. But if it's not been designed, because the first thing let me say is that most of the major connections, in fact all of the major connections, are now being designed. So all your beam to beam simple connections, all your beam to column simple connections, your beam to column frame connections, your base plates, your bracings, all are being designed. But some secondary connections might not be designed at the moment. If that is the case, then they will turn yellow. So there'll be three colors you're dealing with, and you can see it on the legend on the right side of the screen. They'll either pass or they'll fail, or they'll turn yellow, which means they've been done but they've not been checked. Or if it's white, then it's an unrelated issue. Now we have added some reports as well. In the previous version, this particular report was missing, which is the apex haunch. So if I use the apex haunch now, previously we did not have the report for this connection, but now we do. So now, as you can see, previously would have turned yellow because it wasn't being denied, but now it's turning green, which means that the connection is now, the report is now available. Okay, I think this is enough for the connection reports, and let me move on to the new feature which I want to talk about, which is Intelliconnect. Now, Intelliconnect is a revolutionary new idea. You might have heard of things like Auto Connect in other softwares. What they tend to do is, so for example, in a place like this, there's a column, there's an incoming beam, there's an incoming beam from the other side, and there's an incoming beam from the other side as well, and there's a brace as well. This is one of the most complicated cases you will see in your connection, because this column needs to be connected to 5 different elements coming in from all sides. And usually, if you make these connections independently, if you make 5 different connections, if you make the connection between this and this, then you make a connection between this and this, another one between this and this, and then one between this and this, what will end up happening, even if you use what is typically called Auto Connect, that all those connections will end up clashing with each other. And that's a huge problem, because if you have a clashing connection, then it's really not useful, is it? You have to delete it completely and redo it from scratch. So what we developed is, the technology which we developed is what we call Intelliconnect. And what Intelliconnect does is, it doesn't look at each connection separately. It will look at the whole node at that point. It will analyze that node, the finite element node, and it will realize that there are 5 different connections coming in. And then it will look for possible intelligent answers which it can provide, possible intelligent solutions which it can provide. And then it will try to implement those solutions in such a way that there's no clash in the final result. It's constructible, so your hands can go inside. You can bolt, you can tighten the bolts easily. There's no clash between the plates. All those things which you would otherwise have to think through before you make this connection, it will try and think them through. Now, obviously, what we are not claiming is that it will do it for each and every possible scenario you can come up with. But for most of the common scenarios which we see every day in our lives, it's going to find a pretty good solution which is acceptable. And another thing which it does, which is very different from Auto Connect type solutions, is that, for example, I can give you an example over here. For example, that sometimes in steel structures, what you need to do is you need to shift elements slightly to the left or right, and this is allowed. This is not as long as it's the shifts are minor, say 5 centimeters, 10 centimeters. The results don't really impact the final the original analysis. So it's common practice in steel to allow for minor shifting of typically the braces in most cases. So what Intelliconnect does is it will also shift the elements if you allow it to. It's got many parameters which you can tweak. So if you allow it to shift the braces a bit to the left and right, it will even do that for you to make sure that you have a non-clashing connection. So let me just start with the demo. Obviously, there's nothing better than seeing it in action. So how does Intelliconnect work? You might be thinking that it's going to take a lot of learning, but let me show you how easy it is. All you need to do is just select the whole building. You don't have to select the whole building, but you can if you want, or you can select parts of the building and connect them as you go. But what you need to be sure of is that the nodes, these finite element nodes, are selected, because it is based on the nodes that it does all the intelligent calculations. So you select the building and you right click, and there's an Intelliconnect menu which appears. And inside this Intelliconnect menu, you have several options. There's create Purlin connections, create girth connections, there's create sag rod connections, batten plates, stringer plates, splice connections, base plates, bracings, truss connections, floors and beams and columns. I'm going to go through most of them one by one. So let's start with the Purlin connection. So when I press the Purlin connection, it brings up a wizard, and this wizard really makes it very easy for you. These are the possible Purlin connections which are being offered by the program right now. So I say I want the angle connection, but I don't want this angle to be on this side. I want to reverse the cleat. So now it's changed the picture. So once I press the reverse cleat, it's changed the picture, and I just say run. Now, the moment I say run, the program goes through the entire structure, finds the purlins. It goes through the whole structure, finds the purlins, sees if it can connect them or not, and gives you a report. Now, what you see, this done. Oh, it's found so many nodes which are Purlin related, and it's made if it's not possible, if occasionally when it's not able to make a connection, it will show it on the report. Right now, for this particular one, it's been able to do all of them. Let's go and see what it's done. So exactly as I wanted, it's created the purlins, the Purlin connections with the angle cleat, and that's what I was looking for. Now I'm going to select the whole structure again, and this time instead of choosing the Purlin connection, I'm going to go for the girth connection, which is different. Now for the girth connection, I don't want to use the angle cleat. I want to use a bracket with this type of a connection. It's a totally different connection, but the same macro is going to be used. So I just take this one and I say run. And this time it's finding the girths which need to be connected. Now some of the girths are one-sided, some of the girths are two-sided. So for example, these girths are one-sided, so there's just one girth coming in, but this girth over here is two-sided. It needs to connect two. So it's automatically realized at each node what the incoming configurations are, and it's made those connections for me. And in otherwise I would have needed to spend maybe an hour, I don't know, some amount of time to make the girth connections. But now it's just a few seconds. So with this Intelliconnect technology, it really makes it connecting these things in a breeze. Let me go and do the base plates, for example. Let me select the building again, and right click and say do the base plates, for example. Now I'm going to use this particular one. I say run, and immediately it finds all the base plates, possible locations. And if you've noticed, it's checked for those. The fixed ones are connected as fixed, and the hinged ones are connected as hinged, as I showed you previously as well. So while Intelliconnect is running, it's also checking these conditions and trying to come up with powerful solutions. Let's do the splices, for example. Let's select the whole building again. Right click and do the splice connections. immediately you see that the splices have been made. Now I want to show you what I've done, what we've done with the truss connections. Let me select this truss over here, and so this is also to show you that you don't necessarily have to select the whole building every time. And I'm going to ask it to make the truss connections over here, right? So I right click on it and I say create truss connections. I just say run. You can see in the background, it's going over the nodes one by one. These are slightly slower connections because they're more involved. But there's one thing I wanted to show you, which is an improvement over the previous version. And that is this. You can see all the welded gussets have been made, but more than that, the end connections have also been added. So previously we had only these welded connections as part of the Intelliconnect system, but now the truss end connections have also been created on both sides, because that's what I selected. And if I had selected this beam over here, this is also sort of represents the truss, and I had made the truss connections, for example, it would have created the apex haunch over there. So this truss connection includes the apex haunch as well, because this is basically for roofing as well. So instead of putting a separate option for that, it's included in the truss connection part. Now, for the steel column, now let's move on to some of the more complicated ones. The most complicated case which we can do is this case over here. Let's look at, I told you about this particular point. This particular point is one of the most complicated points you can come across, because there are 5 different things coming into that column at that point. And I'm going to right click and I'm going to say Intelliconnect. I could have selected the whole building as well, but just to show you that this is doable in this way as well, I go and say create the column beam connections, right? So when I say that, it comes up with an option, with different options. It says, okay, what if at that point there's an incoming beam with a fixed connection? There are 4 different types of connections you can use. You can use the Haunch connection, you can use the extended end plate, you can use the flange plate moment connection, or you can use the directly welded. Which particular one do you want to use for the fixed connections? So I say, okay, I want to use the Haunch connection as my fixed connection. I press next. Then it says, okay, there might be incoming simple beams as well. And you've got 3 different options for the simple beams. You can use the Stiffen end plate connections, or you can use the fin plate, or you can use the beam to column end plate. So I want to go with the Stiffen end plate one. And then it says, well, there could be some concrete columns as well. They could have some connections, and I can select, in this case, I don't want that. And then it says there could be some bracing as well, and I can make many parameters, many settings over here regarding its shift or not. But let me just press run and see what happens over here. I've selected only this node. So it's going to try to find a solution. If you remember, I said it's going to try to look for a solution which creates an acceptable set of connections at that point. When I say run, it's trying out those connections, and look what it's done. It's created the haunch. It's used the stiffeners of the haunch to connect the beam from this side. It's used the haunch stiffeners on the other side to connect the other one. And then it's also used the haunch top stiffener to connect the bracing which is coming. So it's actually gone on and done a lot of different things, and these are very intelligent features. That's why we call it Intelliconnect rather than AutoConnect. So as you can see, all you need to basically do is just select and right click and say connect this, connect that, and that's what Intelliconnect does for you. And it's extremely easy to use. And once again, I'm going to come back to the first point, which was that if you find steel detailing to be daunting, I'm sure you must have changed your mind by now, because it's extremely simple. Now, one thing I want to say is that you're not limited to these connections. You have your manual detailing buttons available over here. With these manual detailing buttons, you can literally create any connection you want. It can be any, if you can think of it, you can create it. So it's not limited to this kind of a portal frame only. You can make anything you want with ProtaSteel. And to make a manual connection, let me just show you how a manual connection is made, because it's extremely simple. Let me do it automatically first, just to show you the procedure. let's say I have this let's say I've made this connection, and let's say I've made this manually. Let me explode this connection. All right, and let me just hide these things over here. Yeah, and there you go. And let me just hide this as well so it doesn't get in the picture, get in the way. And let me open the cuts as well. Yeah, there you go. So let's say you detail this connection manually. I can make changes, but I don't want to in order not to waste time. But you've made this connection manually. You've used the plate command, the chamfer command, the bolt command, the weld commands, and you've created basically any connection you want. And now you want to add that to the library. You want to give it a name, and then you want to use it elsewhere as well. So all you need to do is you just right-click and you say manual connection, and you say define a new manual connection. Previously, it was the same command was there, but there was a learning curve, so people weren't really using it. So we've turned it into a little wizard. So I want to call it the collision type. So this is the type. There are different types I can use, and I want to give it a name. Let's call it my haunch. Okay, and I say next, and I want to add it to this existing group of connections. Next, then it says select created objects. So I press this button and I select these elements. These are the things which I want to add to the connection. I selected those, and it gives me a little report over here that you've got one cut, you've got 11 plates, you've got one bolt, you've got 32 welds in there. That's fine with me. And then it's next is to select the main and secondary members. So I press the select, and I want to select this beam, and I want to select this column. Right click. Okay, so those are now finished, and I say finish. So it's turned into a wizard. This was previously people were finding it difficult to use, but it's very simple, a simple iterative process. Let me just show all again. Yeah. Now the thing where this connection which I called my haunch, I can just go over here and say create connection using existing definition, and my haunch is there. If you see over there, I just created it. And I can say create the connection, and I can say using this beam and this column, and immediately my haunch is created. So it's extremely easy to create your own library of connections. That's very important, I think, because people usually end up just using what's available on the top and not creating their own connections. But sometimes very complicated connections do require that we use our own connections, and then we can save them away in our library, and we can exchange them between our colleagues, and we can send them to other companies as well, and they'll be able to use these connections extremely easily. Now, I want to move on to connection drawings. Now, connection drawings, obviously, the whole point of creating these connections is not just to create the connection reports, but also to create the connection drawings. Now, for connection drawings, let me just first talk about these little boxes over here. These little boxes you see on the screen. When you make a connection, you can put these little boxes around those connections. And what these boxes are, if you double click on them, what these boxes are they can show you the 6 different views looking into that connection: the red, the green, and the blue. The red is from 2 sides, the left and the right. The blue is from 2 sides, the top and the bottom, and the green is from 2 sides, the front and the back. And you can create 6 different views, and you can also create 3D views. And so you can really, because in a connection drawing, that's what you want. So let me just show you something I've done over here. Okay. Yeah. So what we've done over here, what we've added, which is new, is that previously, when we did this, we didn't have the option of joints. Now you have something called main joint ID over here, and this wasn't there before. So we would only add the steel parts which would enter the connection and not the joint ID. But now we are adding a joint ID over here, and the reason we are doing that is for something what we call connection grouping, and I'm going to show you that in a minute. So just remember this box, and remember the fact that I showed you a joint ID. Yeah, and once you've created these joint IDs, I'm going to go to an existing drawing. Let me just go there. open the facade drawing for that facade. Yeah, there we go. And those boxes, if you remember, there were 3 boxes in that facade. They will appear on your drawing as these little circles over here. These circles are the 3 boxes which we just showed in the model. And now the thing is that the reason why we included the joint over here is that when we're going to detail these connections, we want not only to say that, okay, this is the detail, this is called splice 1, but we also want to show where else in the model the same connection exists. Because what we don't want to do is create thousands of these boxes all over. We just want to create 5 or 10 or 15 of these boxes in the model. And then we want the program to look for other places in the model which are similar to those places, and automatically find them, number them, and then give us the drawing accordingly. So let me just take you through that step. It's actually exactly the same as before. So there's no learning curve over here. All you need to do is just go to this button over here. If you have a setting which you want to load, that's fine. And you just press that button. That's all you need to do. So you press that button and you wait, and your connection, you've got 3 different connection types over here. Now, first, let me go through this. So this was called splice 1, this connection. But what it's done is it's also found that there's another splice 1 over here. And it's the node situation is exactly the same as the node situation over here. That's why we now include the nodes in the definition. So this was splice 1, but the program found that, okay, hold on a second. There's no box around this one, but this is also splice 1. And there's no box around this one, but this is also splice 1. So what it's done is it's done a joint numbering, which is extremely complicated, because all the approach angles and beam types and approach angle tolerances and the different conditions, like so many different conditions are involved. They need to be checked and compared, and they could be mirrored and they could be rotated, but the program will find out all the possibilities. So for this one, for example, it says base plate, but then it says, okay, there's another base one over here as well, and there's another one over here as well. So it's looking for the similar things in the model, although you've made just one box, but it's put the labeling all over that facade, right? And that's a huge advantage because you won't have to go and name these things on your drawings one by one. And let's go and check the drawings. You can see that they have been labeled, they've been annotated. Even the 3D views I have included over here. Over here, I'm including the 3D view of that complicated connection, which are, you can move these things around. You can label anything extra which you want to label. You can add dimensions if you want. We are working on ways to at least partially automatically dimension them right now. At the moment, you have to add the dimensions yourself, but hopefully in the coming versions, we will produce this as well. So as you can see, it's extremely easy to just by pressing a button. As you just create your boxes in the model, and let me go back to the model. You create these boxes. You can create as many as you want, but like I said, typically you will be talking about creating maybe about 5 or 10 or 15 of these. And then you just go to the drawing and just press that little box button on the drawing side, and all your boxes will be detailed out for you. And if similar situations occur elsewhere in the model, they'll also be annotated. This is what we call connection grouping. So this is something, it's a new feature. It's extremely useful. Otherwise, you would have to look for all the other similar situations yourself in the previous versions, but now you don't have to. Now, let me go and show you, talk about shop drawings now. Now, shop drawings is obviously where a lot of the meat is. If you're a consulting company, you might not be that interested in producing shop drawings, but if you're a fabricator, or if you're a consulting company which wants to get into this business of fabrication and production of shop drawings, then you will know that this business requires many man hours, and a lot of man hours are involved. And but ProtaSteel is not about creating just connection drawings. Once you have your model ready, once you have made the connections, as you can see, this is a model in which it's already connected. You can produce your general arrangement drawings, you can produce your shop drawings, you can produce your single part drawings automatically. All you need to do is just select the elements and right click and say create drawing. You can create a part drawing, or you can create an assembly drawing. A part drawing will be for a single part, and an assembly drawing will be for the whole assembly. Now Let me just go and show you some results over here. So let me go to the drawing manager. So the facade I've already shown you. Let me go and check one of these assembly drawings over here. So as you can see, all that haunched beam has been detailed, dimensioned. The welds are given, the plate thicknesses, the locations of the plates on the assembly. They've all been done, and this is where you save the man hours. The material lists are there. The bolt list you can enter if you want. You can enter all. It's very customizable. Everything you see on the screen is customizable. The dimension tolerances, the dimension colors, the annotation styles. They're all. I can't go into the details of that, but it's all customizable. And let me show you another one over here. So this is the truss, for example. This is important because truss drawings are usually not handled well at all by most commercially available software. But you will see on your screen in a bit that ProtaSteel is able to really handle these drawings extremely easily. There you go. It's a huge drawing. You can see all the dimensions are there. It's a very well constructed drawing. Otherwise, you would, in a typical commercially available other softwares, you would have seen a hodgepodge of dimensions all running into each other, because trusses are very special and trusses need to be detailed and dimensioned in a very particular way. Now, I want to give a summary. Of what we've done. That ProtaSteel is not about just using macros. ProtaSteel has a lot of features with which you can create. I'm going to show you something in a second. With which you can create basically anything you want, and so you don't ever feel that those advanced softwares which are available in the market, which are sold for tens of thousands of dollars, are way better than ProtaSteel, and because they're not. This is something you can do with ProtaSteel. What you're seeing on the screen is something you can do with ProtaSteel. Just look at that. Some of this has been detailed by the automatic connections, and some of this has been detailed by the manual connections. But what I wanted to basically show you is just to give you an idea that you shouldn't feel that they keep showing this portal frame all the time. But that's only for the webinar purposes, because we can't use a model like this in a typical webinar setting. But just to show you that this is the kind of stuff you can do with ProtaSteel. This is the kind of output you can get with ProtaSteel. And as you can see, the sky is the limit. This is a very large project. It's got all sorts of stairs coming in and out, platforms coming in and out. With ProtaSteel, there will not come a day when you will say, well, we did most of it, but there was one part of the structure which we couldn't finish, so we had to revert to AutoCAD or something like that. This is an extremely complicated structure which we've done. You can see these connections are all manual connections over there. But the point which I want to emphasize over here is that this is what's possible. Now, obviously, we have smooth integration with other softwares. Even with Tekla, we've got IFC-based communication with other softwares, and it's got a fully integrated functional CAD package within itself. So you don't need AutoCAD to work with ProtaSteel. ProtaSteel has got its own AutoCAD inside it. It's got its own drawing software inside it, and hopefully, with this one single piece of software, you will not be left behind, and you will not have to revert to anything else. So let me just quickly go back to my PowerPoint slide. Yeah, so we left it over here. So let me just summarize. So automated connection design for your projects. Intelliconnect, we talked about that. Automatically assesses joints for your preferences and batch designs. Wide range of simple moment, splice, and weld connections. Considers the constructability, which is huge. Adjusts connection arrangements to suit. That's Intelliconnect for you. It can model additional ancillary steelworks with the complete detailing. It's got intelligent presets, so your company standards are in there. Once you have given the program your time and you've inputted your company standards, it will know what your company wants, and you will not be redoing those things again and again. It will automatically override the design results if your company standards are higher, for example. It's got automated design reports, as we just saw. color coded by green and red and yellow, easy to see immediately, and they provide very concise design reports with details, clause by clause code checking. So every single clause of the code you can check and you can send to your client. So that'll save you a huge amount of time and money. And then you've got detailed drawings of your projects. So this is where you spend most of your time. You can see the assemblies, you can create fabrication details with ease, you can create full fabrication details with full quantity takeoffs, right down to the last bolt, the parts and part drawings, the assembly drawings, the NC data for the shop and steelwork. You can share your complete model with using the BIM standard with our other software like Tekla, and between Tekla and ProtaSteel, with Tekla and Revit, with Allplan, all these other softwares which are out there in the market. So don't think that we've got everything now in ProtaSteel. How do we communicate? You will be able to communicate using our interfaces. You've got the full calculation documentation for all regular connections, all the regular connections, all your simple connections, all your moment connections, your base plates, your braces. Those are the things which are important. And now we have all of them. And what's new, what I've showed you new, is the full calculation documentation for all the regular connections. We just talked about these a while ago. And then we talked about new modeling connections as well. So we talked about the wind column connection. We didn't talk about all of them, but yes, they're there. The stairs connection. We talked about castellated beams. We talked about handrails. Lots of things we talked about. Some things I didn't cover, I couldn't cover because of lack of time. And then we talked about connection grouping, which is extremely important. That once you put a box around one of these connections, the program will automatically find if there are other similar places in the model. So if you put so you don't have to make hundreds of these boxes all over just to get the numbering done. You just make one box. You make sure you're looking at it from the right directions. You press the box button, and your drawings are created, and the other similar areas are labeled as well. So PC15, for example, over here was made by the box, but the other PC15s have been detected by the program automatically, and they've been labeled accordingly. So the growing global code coverage, as you can see, all these codes are now part of the ProtaStructure suite, from BS to Turkish standards to ASC to MS to DPT to ACIs to the LRFD standards. There's a whole bunch which are now being integrated, and you can clearly see that this is a global suite. It really caters for the global market, not just for some local markets. And this shows by our users all over the world. ProtaStructure is used by thousands of leading engineering consultants around the world to design, to analyze, to design, to model, to fabricate, for all the various steps we talked about, and to deliver their projects very quickly, very efficiently. It's all about man hours. These days, we're living in an age where you can more or less do all the stuff you want by using the different softwares. Obviously, if that wasn't the case, those softwares wouldn't be selling. But the question really is, how integrated are they? How much time do you spend using those softwares? If you spend a month doing something, the cost is X. But if you spend 10 days doing the same thing, well, then obviously the cost is going to be different. And thank you once again, and hopefully see you next time.